So a quick show of hands. Who has heard of MicroVMs? Nice, cool. Has anyone used MicroVMs? One, good. Well, did you use Firecracker Cloud Hypervisor? Yeah, cool. Well, that's more than normal. So what actually are MicroVMs? So I'm going to start with the word microVM, so that implies a lot of things. So with the first part, the micro part, that sort of indicates something very small. And when people see that they make certain assumptions about, this thing is very, very small. And it's an adjective, so if we're talking about English, it's a modifier word. It indicates something about a noun, so the thing that follows it. So what we're saying here is the noun is the VM part, so everyone knows that is an acronym for virtual machine, so a virtualized or emulated computer system. So when we take these two things together, it's a question for everyone, does a microVM equal a very small virtualized or emulated computer system? The word implies it, and actually the answer is not necessarily. So this is where a lot of people, think the thinking goes wrong. So this was actually pointed out to me, helpfully on Twitter when I posted something about microVMs. Whilst I don't agree with both of the comments there, I actually agree with the sentiment of the first comment. If I'm running a Kubernetes node in a microVM, is it actually micro? Probably not. But I much prefer someone else's comment that liken liquid metal to the T1000. So that was a lot better for me. So I've said, what microVMs are not. So they're not very small, lightweight virtual machines. So what actually are they? First and foremost, if you take one thing away from this talk, it's just lightweight virtualization. That's all it is. And what this really means is it's a minimal VMM that utilizes KVM. And when we talk about microVM implementations, they normally focus on or prioritize three areas in their implementation. So the first is security. They want a smaller attack surface, so there's less vulnerabilities, and depending on your implementation, this may include things like cgroups, seccomp filters, and things like that. Secondly, they're designed to be fast. Now, if you look into microVMs, you'll see all sorts of numbers published. This one here that is quoted about Firecracker, less than 125 milliseconds to launch. That sounds really, really good. If I saw that, I'd be like, yeah, that's amazing. And that's to launch the Firecracker process. That is not to boot your guest OS. That is on top of this. So take those numbers with a pinch of salt. But they are designed to launch hundreds of these microVMs every second per host. And there's reasons for that. The third area they prioritize is efficiency and scalability. Now, what this really means is the resource overhead per VM should be minimal. And in most implementations currently out there, this is less than 5 megabytes per VM. So they try and minimize that. So moving on to the devices. So what does this virtualization support? So it's limited. That's where this micro aspect comes into it. So it supports a limited set of devices or a limited device model. It doesn't try to emulate all the things and be a general virtualization solution. It's not that. It uses power virtualization, so the guests are aware that they're running within a virtual environment. Essentially, depending on your implementation, there may be varying levels of VirtOIO device types implemented there. But what this all means is there is less bloat, less hypervisor bloat, is how it's commonly termed. It has a faster startup time, and because there are less devices supported, there's less code in there and less attack surface, essentially. So all of the microVM implementations have a concept of volumes. You have to have a root volume to boot the microVM. These are all implemented as raw file system files or block devices. And these can be really, really cumbersome to work with if you've ever had to use those. So this is where overlay file systems come in, or DevMapper. Some implementations, some solutions that are built on top of microVMs go so far as to take a container image, do some magic behind the scenes, and present that as a block device to the microVM implementation. So it sort of takes away some of the pain of dealing with those raw file systems. Now also, depending on your implementation, there may be no BIOS and no bootloader. The microVM implementation, such as Firecracker, will start executing the kernel directly. It will go to a magic entry point, and then it will start executing from there. So that also increases the startup time, or improves the startup time. Most implementations come with an API server built into them. And now this is a per instance API server, and it's usually accessible via socket. Now what this allows you to do is perform configuration against your microVM. So add a network interface or a volume. But it also allows you to perform operations. Now the operations that you can perform depend on the implementation you're using. So it could be start, stop your VM, or take a snapshot. Also, depending on the implementation, they might have a metadata service built in. Now this is super useful. So this allows you to place information in from the host into the metadata service and have that information available in the guest. Now this is commonly used for things like cloud init. So you can put your cloud init from the host and get it to boot, or use it during the boot process of that microVM. Lots of other people also use it to pass in things like secrets. So if, depending on your use case, you might need a secret within that guest VM, so you can use the metadata service to do that. Now moving on to why should you care about microVMs. So I guess fundamentally, it allows you to do more with the same amount of tin. So if we have a bare metal machine here, and I want to run a VM on there, so there's two parts to it. So there's the resources required for the guest, and then there's an overhead per VM. Now, if I'm using a microVM implementation, the resource requirements for the guest are the same, but the overhead is less. So that basically means, I can run more on that machine. And then if you think about edge and far edge, where the amount of compute is limited, this really, really makes a difference because it allows you to run more things on that machine. So some of the use cases, the big one that is always talked about is workload isolation. So this is essentially because you're running within a virtual machine, it's more isolated than a container. And now you might want to do that for regulatory, operational, or data privacy issues. So I spoke to someone that was developing a data pipeline as a service solution, and they wanted to allow customers to run their own custom steps. But they didn't want to expose the rest of the pipeline to that code that came from the customer, so they decided to run that individual step within a microVM and isolate it from the rest of the process. This is close to my heart, so this is what we did. We essentially run Kubernetes clusters, or the nodes within microVMs, and that allows us to essentially have lots of smaller clusters and potentially give one to every customer or one to every team, instead of having a smaller number of large clusters. And there are lots of other examples out there in the wild. Some of the most interesting ones are using microVMs to run isolated build pipelines. There's a really good video of someone called Alex Ellis, who's using it to run GitHub runners locally, compile kernels and stuff like that take forever in normal GitHub Actions runners. You can use it to create, because of the speed and the resource requirements, it's a really good solution to creating testing environments and preview environments on pull requests. So you can just spin up these environments, very lightweight. So how do you use microVMs? So essentially there's two main implementations that I think about as microVMs. There's Firecracker and there is Cloud Hypervisor. They both have a similar heritage. They both started out via cross VM. They both use the Rust VMM crate. But depending on their use cases, they have now diverged slightly. There are other solutions now. So there is the QEMU Micro, but this disappeared after Firecracker and Cloud Hypervisor. Both support x86 and ARM. And essentially what you have to do is create an instance of Firecracker or Cloud Hypervisor per VM. So essentially a process per VM. So if I move on to Firecracker specifically, so this was used, well, this is used and developed by AWS. It underpins AWS services, so specifically Lambda and Fargate. Now what this also means is it's designed for a very specific use case in mind, which is ephemeral compute, and that drives the features that are within Firecracker. And this really translates into a reduced device model. So there is no PCI pass-through, for example. There is no Mac VTAP support because it's not required to run in AWS. So the features are driven essentially by that. What it does have a metadata service. So I can use that to do cloud init if I want to on boot. But because of its ephemeral nature, it has no concept of pause or reboot. So it's just a start or a stop. So you need to be wary of that if you're going to use Firecracker. You can increase the security of the Firecracker process. You can start Firecracker via something that they call the jailer. And that essentially then forces the Firecracker process to be started within a network namespace, using seccomp filters as well for the system calls, and cgroup to limit the resource usage. So you can really, really lock the Firecracker process down. One thing to note is you can only use it for Linux guests. Secondly, there is Cloud Hypervisor. Now this is a project started by Intel, Alibaba, and a few other companies. And it's a more generalized virtualization solution. And it's a bit more feature-rich as a result of this. The device model it supports is greater than Firecracker. So it has a lot more VirtIO device types supported, specifically things like VDPA, if you're interested in that. It supports PCI pass-through. So if you have machine learning workloads you want to run in your microVMs, great. Also, if you use an SRIOV as well, this is an option for you, which Firecracker is not. If you're interested in secure compute and enclaves, it also supports TDX and SGX as well, which Firecracker doesn't. And it supports Mac VTAP out of the box. So I should caveat that Firecracker does have a feature branch open with Mac VTAP support as well. There is no metadata service in Cloud Hypervisor. So if you want to get information in and out of your guest VM, you're going to have to use something else. So you can attach a volume if you want to do that. Whether it's a good thing or a bad thing, it supports Linux and Windows as guest operating systems.